Hey guys, what are y'all doing?
We're basically building a parallel circuit, and to do that, we need KCL and KVL. If you don't know what that is, it's Kirchoff's voltage, and Kirchoff's current law determines the amount of current that goes into and out of the circuit, as well as the amount of voltage that comes in and out of the circuit.
Oh, for real? Can you explain to me a little bit more what all this is about?
Basically, we're running a voltage from this Arduino microcontroller all the way through this breadboard. We're just choosing which rail to take the output and send it through an LED. And in order to prevent it from popping, we're just going to install resistors whenever needed. This circuit right here is our mathematical representation. Essentially, we're going to be using the KVL and KCL, voltage and current law, as well as Ohm's law, current times resistance equals voltage. We have our two voltage sources.
One is going to be 5 volts, the other is going to be 3.3 volts.
We're going to consider these two to be two closed loops independent. Sum of all voltages in a closed loop will be equal to 0. We can use that to our advantage. From this voltage, drop over to these two voltages, go back into this negative terminal. Done. Same thing over here. You can start at the 5 volt and then go across these two resistors, drop, and then go back into a negative terminal. 3.3, 5s. These are going to be the sum of voltage drops, and they're going to be equal to 0. We're going to be using KCL for our third equation. Note that these two currents are going into this one node. I2 is going to be the only current that's going out. So the sum of currents going into one node and leaving should be equal to each other. That's what we have, and that's what we got. And put them into a matrix. We have a 3x3, and anywhere that we don't have a variable, we replace it with 0, and this we have the entire set. And that's going to be multiplied to the current, and that's how we are going to get our voltages.
And then from this point, we can use any number of ways to solve from this point forwards. We could use Gauss-Jordan, you could use Cramer's rule, inverse, etc. There's numerous ways to go about it.
Oh really? So that's what y'all have set up over here?
Oh yeah?
Yep.
Do you mind if I try?
Oh yeah?
Absolutely.
Go ahead, go for it.
Okay, so now we connect it to the power. That was kind of anticlimactic.
Kirchoff's current law and Kirchoff's voltage law are not just classroom concepts. They are the foundation of how all modern electrical systems operate. In our mini parallel circuit, we saw how current splits at a node and how voltage is conserved around a loop.
Oh wow, is there any examples of where it's applied in the real world?
These exact same principles scale directly to real-world systems like printed circuit boards or PCBs in every electronic device, including phones, computers, and vehicles. On a PCB, thousands or even millions of tiny components are connected through complex networks. KCL ensures that current is properly distributed across these nodes. KVL guarantees that voltage is conserved across loops, allowing engineers to design circuits that function reliably and efficiently.
Is there any large-scale applications?
These laws are also in large-scale systems like power grids, where engineers rely on them to model and analyze energy flow.
Interesting.
Maybe let it sit for a few seconds.
This is a 3.5 or it should burn.
That's the 5
It's
volt.
the 5 volts, so. Huh.
What did you do earlier, Isha?
I just put it into this terminal over here. I thought, I mean, it should carry the same current.
What did we do?
What is going on?
These things should be burning out, because these things have super low input.
Can you try this one? This one's... Actually, not. This is charged.